All right, so now that we talk about life and how it formed on the Earth, let's talk about, are there places in our own solar system where life may have formed and we just haven't found it yet? So, the most likely place is actually Mars. Why? Right now, Mars is not a nice place for life, but it wasn't always this way. Now, a couple of key facts about Mars. The biggest difference right here is up here. Mars is 1/10 the mass of the Earth. That's its problem. Excuse me. Remember I said that that the planet had to be large enough to hold on to its atmosphere to support life. Well, Mars, when it formed 4.5 billion years ago, was probably very similar to the Earth. It probably had a nice thick carbon dioxide atmosphere, and that carbon dioxide atmosphere would actually keep it warm enough so liquid water existed on the surface. In fact, we know for a fact it used to have liquid water on the surface of Mars. They have found the leftovers, the remnants of this liquid water in all of the explorers that have been sent to Mars. So we know there was liquid water there. And like we said before, if you have liquid water and the right chemicals, we think it's very likely that that life was created. However, over time, Mars being too small, slowly started to cool off. And once it started to cool off, its atmosphere started to freeze and go away. And then pretty soon now it has an atmosphere that is so thin, it's about 1/1000th the pressure of our atmosphere, that it can't sustain life. In fact, you can't even have liquid water on the surface of Mars because the atmospheric pressure, it'll immediately boil away into the atmosphere. So you can only have water in a frozen form at this point. Its average temperature is minus 55 degrees Celsius. That's cold, right? That's about minus 70 degrees Fahrenheit. That's the average temperature. Now, occasionally, if you're at the equator in the summer, you might get up to 50 or 60 degrees on Mars, but it doesn't last for many days. Most of its year, it's spent in the negative time. Notice its year is about twice our years. It's 687 days for 1 year compared to us. It has high winds, but the high winds with such a low density are just more of an annoyance than anything else. I told you about, if you've seen the movie The Martian, the premise is that the winds come up and they're going to blow over the rocket ship and they have to get off, and one guy they think dies, they leave him behind, they find out he survived. That's the premise for the whole movie. But the wind would never have knocked over their rocket ship, even though you can get winds at 144 kilometers per hour. I mean, that's fast. That's like a 100-mile-an-hour wind. It wouldn't knock the rocket over because the air is so thin, it just goes right around it. It just kicks up dust storms so you can't see, but it wouldn't knock over your spaceship. All right. So, Mars, possibility. So this is typical surface of Mars. This was done, I think, by the Spirit and Opportunity were two rovers that they put up there. Lasted for a long time. In fact, they hoped they would last for about 3 months, about 90 days. Both of them ended up lasting more than a Martian year, more than 680 days, and Opportunity lasted almost 2. They thought there's no way that these probes could survive a Martian winter, because the Martian winter makes Antarctica seem nice, but they did. All right, but you can see here's the tracks of it driving away. It drove itself up here. There were cars, they could drive around the surface. This, 90% of the surface of Mars will look exactly like this. Almost anywhere you landed would look almost exactly the same. There's not a lot of difference. Unless you were close to the poles where there's polar caps, it's not a lot different. Now here's the polar caps. One of the interesting things about the polar caps is they have a layer of carbon dioxide ice, dry ice, frozen on top, because it gets so cold that the carbon dioxide, which is in the atmosphere, can just freeze right onto the ground near the poles in the winter. But below that, all this underneath here is water ice, frozen water ice, both poles. So it has thick layers of ice deposits. If Mars was warm enough so you could melt those poles, you could completely cover Mars in about 3 to 4 feet of water, the whole planet. So there's lots of water there, similar to our polar caps. That's what our fear is. If we melt our polar caps, our sea levels are going to rise and put all those cities on the coast in jeopardy of being underwater. Okay. One of the things they found too as they landed, this was one of the probes that landed fairly high latitude, but it wasn't actually at the pole. It was away from the polar cap, and they dug under the dirt with a little claw that came out, and they found ice. They dug down about 3 inches, and they found ice. So not only is there water in the polar caps, but even under the ground further away, there's still water. It's just frozen underground. It's in a permafrost condition. We see the same thing in the Arctic, where there's land that never unthaws in the summer. We call that permafrost. And the water is just frozen into the ground. Well, we see the same thing on Mars. Okay, and where you have water, remember, there's a good chance of life. You see this was all created by a river. Mars at one time had flowing rivers and lakes, and it had the whole water cycle. Remember, early on, Mars, actually because it was smaller, cooled off sooner than the Earth, so it could have become a nicer, more habitable spot sooner on. It would have had a nice, thick, warm atmosphere. It would have been carbon dioxide. It would have had flowing water, whole water cycle going on. But then things turned cold, and that was the problem. And now all the water is gone, or it's all frozen away. So this is the way we think it was. We think 4 billion years ago, there were oceans of water on Mars. You see these oceans covering it, and then over time, Mars starts to cool off. What happens is that water starts to freeze into the polar caps. 2 billion years ago, 1 billion years ago, now there is no water except frozen water in the polar caps. There's no liquid water at all. So the question is, was there life back then? Definitely a possibility. Remember, we know that on Earth, life formed right away. 4.1 billion years ago, we had life starting on Earth. Mars, it had the right conditions, it had the same molecules, it had liquid water. Probably, but then all that life died out. So one of the things they look for now is there any remnant of that life? Fossil remnants, stromatolites, things like that that would have been left over from life, just to see if life existed somewhere other than the Earth. As of now, they have not found any proof. They keep finding interesting things. One of the interesting things is this is methane. Remember I told you methane is often released by organisms, living organisms. And one of the probes up there would measure the amount of methane there was all year, and you notice in the summer, the methane goes up, and then as it goes down again. This would be a typical of microorganisms that would become very active when it was nice and warm, and then they would freeze off in the winter, and they could be releasing that methane. It's also possible it's a chemical reaction undergoing in the ground, and it actually has nothing to do with life. We don't know enough yet, but this is suggestive. So it's still possible there may be life, probably microbial life, on Mars, or it could be just a chemical reaction. We don't know for sure. Now the Viking missions, these were sent back in 1970s to Mars, so these were some of the earliest ones, and they tried to find life. That was their whole goal. And they would scoop up soil samples, and they would add chemicals to it, and they would see if anything happened. Like they would see if there was any reaction with the chemicals, they would see if there's any release of different gases, a gas exchange experiment, and 2 of them showed no activity at all. The third one showed activity, but not the kind of activity you would expect with life, meaning it was more of a chemical reaction, everything happened really quick and then it stopped. Where with life, if you have it, life would just continue like releasing gases over time. It wouldn't be an instantaneous thing and then stop. That's usually a chemical reaction where the chemicals just interact with the soil. So that's why back then they pretty much said, well, we don't think there's life, but we really still don't know. And here we are, 40 years later, we still don't know. All right, but possible, and this is really what's driving the sending probes to Mars. And pretty much every 2 years they keep sending probes to Mars, because that's when the Earth and Mars line up good enough that you can send a probe to Mars. And every 2 years we've been doing it for the last 20 years, and they plan on continuing doing it. The idea is to continue sending cars that can drive around, different orbits. Right now I think there's like 20 satellites orbiting Mars that send back information. And eventually the goal is to send humans. That's still a possibility sometime. They keep pushing it back. Back in the 1990s they said we'd have somebody there by 2020. Here it is 2020. We're nowhere closer. Now they're saying 2030. We'll just have to see what happens. So, but we have been very good at sending robots to analyze different things. Now, our problem is they all have to analyze it there. One idea is to grab samples of the soil and try to launch it back to Earth, where we have more sophisticated laboratories. That has not yet been done either. All right, other places in the solar system. One is Europa. Europa is interesting. Europa is a moon of Jupiter. And Jupiter has 4 very large moons, Io, Europa, Ganymede, and Callisto. Europa is this is a ball of ice. This is all water ice frozen on the top. And we see more ice as we get further out in the solar system. But under that layer of ice is a ocean. Liquid water ocean. So there's ice here, and then there's a liquid ocean. Why? Because it's close enough to Jupiter that Jupiter actually puts out infrared heat, and its tidal forces kind of stress and compress the moons as they orbit it, and so that what it does is it heats up that water. So the water underneath is liquid, and the top part turns to ice because space is very cold. There's no atmosphere. But there's this layer of ice. The question is, could life exist in that ocean underneath it? And there are lots of intriguing things that people keep finding, saying, we see these venting. There's cracks through the ice. Now, the ice can be miles thick. It depends on where you are. In some places, it can be smaller. And we see these fractures where ice can flow up. It immediately freezes. Here, this warm water down here can get sprayed up in these vents, meaning it gets hot enough it sprays out onto the surface of Europa. Is it possible? It is possible, maybe. And this is, remember, this is all speculation. But it is possible that deep down in here, you have all these chemicals, and there could be different kinds of life that could survive in those kind of conditions. Possible. One of the things that NASA is thinking about is trying to figure out some way to send a probe to Europa to try to learn more, especially to look where these